Hi Calculus students, welcome. We are working in the packet still. This is the date May 4th in the packet. 2013, question number 2. The topic is a position function. Position, its derivative velocity, its derivative acceleration. You can see here on the board, here we have the equation that we're dealing with, -2 plus blah 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 blah. And I started the problem by taking this and plugging it into y1 in my graphing calculator. So in y1, I have this. Alright, part A says find the values of t on the interval for which the speed of the particle is equal to 2. Now this is a little bit of a tricky question because we haven't really talked about this. Speed. What is speed? Alright, so let's say you're driving in a car and you're driving 65 miles per hour. Okay? You might think of that as your speed. Velocity could be positive or negative. So, if I was going 65 or negative 65, what would the positive or negative basically determine? Well, if a particle is moving left or right, when the velocity is negative, the negative is just telling you the direction it's going to the left. So, the speed is 65 miles per hour. The negative tells you it's going to the left. Likewise here, if you had a positive 65, the 65 tells you that's your speed. You're going 65 miles per hour. And the fact that it's positive says you're moving to the right. So moving to the right, moving to the left. And they both stem from the speedometer saying 65 miles per hour. So what is speed? Well, either one of these, if you go ahead and make it positive, is speed. Speed, and this is important, so I would basically make sure to write this down. I was really hoping we'd be in class for lessons like this, but we're not. Speed is the absolute value of velocity. So the absolute value of velocity is speed. So take velocity, make it positive, that's speed. All right, so why is that important for this question? So for this question, they ask when is the speed equal to 2? So we want to know when is the speed, this is speed, equal to 2. Again, this is part A. Now I told you I plugged this into y1 in my calculator. I'm going to use hotkeys to help me out. I'm going to put absolute values, and in y2 in my calculator, I'm going to do the absolute value of what's in y1. Now you could just type in absolute value and plug all this stuff in, that's fine. But I'm just going to speed things up. So I'm going to graph the absolute value of velocity in y2 in my calculator. If you forget where absolute value is, you hit math on your calculator, go over 1 to numbers, and it's ABS. So math over to numbers, ABS, and of y1. And I want to know when will this equal to 2. So I'm going to plug this in one of my places. I'm going to plug 2 in the other. So in y3, I'm going to type 2. And this is how your calculator solves things. So I put this one in one of them. I plug this one in the other one. And I'm graphing both. And I want to know when they're equal is their intersection point. So I graph them both. I change the window from 0 to 5 because that's all I care about. And I notice it intersects several times, but they only want to know from 2 to 4. So from 2 to 4, second calc intersect, and I find the intersection that's between 2 and 4. And I got 2 answers. My first answer is 3.4734. And my second answer is 3.128. I should probably keep another decimal. Let me just use my calculator to find this. I was looking the answer online for that second part. All right, enter, enter, enter. 3.1276. All right, so speed is the absolute value of velocity. These are the times when its speed is equal to 2 on the given time interval. All right, let's go to part B. So part B says, write an expression involving an integral that gives the position s of t. And then use this expression to find the position of the particles. This is a two-parter. You want one to find an expression that gives the s of t. So what is s of t? Well, s of t is the position function. And to find any position, you first need to know what is your initial position. Now in this problem, they gave you one piece of initial position. Your position at time 0 is 10. So if I want to know my position at any time t, it's my initial position plus my net change in position from time 0, that's when I begin, all the way to time t of v of t. I didn't want to write the whole equation out. So my position at any time t is my initial position, which is 10, plus, and again, the area underneath velocity gives the net change in position. So this will give me my position at any time t. They asked for this. We've never seen a question where they ask you to write the expression. And now they say use this to find the position at time 5. Well, if I want to know my position at time 5, if I'm comparing positions, time 0 occurs before time 5. All right, so this is my initial, this is my final, and my final position is my initial position plus my net change in position. So what's the area underneath velocity from time 0 to time 5? It's going to be area underneath velocity gives displacement or the net change in position. This is in y1 in my calculator, so I'm just going to type in 10 plus that. So 10 plus, and the math 9, integrate it from 0 to 5, and then whatever's in y1. And of course I hit a wrong button. Alpha traced for my hotkeys for what's in y1. And I got the answer, and I'm making sure it matches the answer here. Negative 9 point, yep. So I get the position at time 5 is negative 9.2073. Okay, that is the end of part B. Now we move to part C. So important information for part C. They want to know, when does the particle change directions? When velocity is greater than 0, a particle is moving to the right. When the velocity is equal to 0, a particle is at rest. And when velocity is less than 0, a particle is moving to the left. So if I made a sign chart of velocity, so let's say velocity looks like this, and here I have a 2 and a 5 and a plus, minus, plus. Just an example, it's not this problem. But here it meant the particle is moving to the right, and then the particle is moving to the left. So this would represent when it changed directions. It was going to the right and then to the left, so it changes directions, and then from the left and then to the right, so it changes directions. So when velocity changes from positive to negative or negative to positive, it goes from right to left or left to right, meaning it changes direction. So I'm going to go ahead and graph velocity. It should be in y1 in my calculator, and make a sign chart of that graph. So I'm going to go to y1, make sure that all the other graphs, I had stuff in y2 and y3, I don't need them anymore, I'm clearing them out. I'm going to graph what's in y1, and I'm going to make a quick sign chart. So this is what my graph looks like when I graph it. So those of you who don't have a calculator, you can go to Desmos.com to graph. 1, 2, 3, 4, 5, here-ish, and here-ish, and the graph looks a little bit like this. Oops, sorry. It goes down much more severely. But anyways, this is my graph of velocity. So I need to figure out what are those 2 points. So I'm going to find the zeros of the graph. So I go to second, calculate 0. And it says go to the left. So I have to go all the way to the left, I hit enter. I go to the right, I hit enter again. Guys, is it a game to make as much noise as possible out there?
No, we're working on a new game.
Alright, you did it. Alright, anyways, time is 0.5360, and then I want to find the second one. Second calc 0. Go to the left, go to the right, and I get 3.3177. So if I made a quick sign chart of velocity from time 0 to time 5, we have over here 0.5360, and over here we have 3.3177. All right, and then it's below the curve, above the curve, below the curve. Notice I labeled it as velocity. You've got to label these sign charts so the AP exam can give you credit. Again, below the curve, above the curve, below the curve. So it was moving to the left, and then to the right, and then to the left. So these are your answers. So you would say, change directions. Because notice I'm repeating what they asked. So change directions at time equals 0.5360 and time equals 3.3177 because velocity changed signs. Now you could specifically say change from positive to negative or negative to positive, or just change signs is fine. Alright, they're playing whack-a-mole, that's fine. If you guys hear some noise in the background, what a game to play with videotaping whack-a-mole. And again, it's fine. You guys can keep playing, you're doing great. Alright, last question, part D. Is the speed increasing or decreasing at time equals 4? Now, speed we already talked about earlier as being the absolute value of velocity. But here in this question, is speed increasing or decreasing? Remember a long time ago we had some rules. So, speed increases when velocity and acceleration, we're on part D, okay. When velocity and acceleration have the same signs. So if velocity and acceleration are both positive or both negative, speed is increasing. And speed is decreasing when velocity and acceleration have different signs. Now, in the past, we have made two sign charts, a sign chart for velocity, a sign chart for acceleration, and line them up. And we use that to determine basically when intervals when speed's increasing or decreasing. But here they specifically care about at time equals 4. So all I need to know is what's my velocity at time 4 and what's my acceleration at time 4. Now, I actually can use my sign chart here and see my velocity. 4 is between these two. My velocity is negative. But what if I wanted to know my actual velocity? I can take a 4 and type it into there. Now that would take forever. So in order to type this in really quick, I'm going to go to y1, going to type y1 in my calculator, and then put a 4 in parentheses. So I'm going to be on my main screen. I hit alpha trace, use y1 for the hotkeys, type in a 4, and I get negative 11.4757. But I only care that it's less than 0. That's all that matters. And now I need acceleration. Now acceleration is the derivative of velocity. And I'm not taking the derivative by hand. I could, but I don't need to. I can use the Math 8 button on my calculator and tell the calculator to take the derivative of, I'm just going to tell it to take the derivative of what's in y1, take the derivative of velocity at time equals 4. And it will take the derivative, plug in 4 for me. So I hit Math 8, use my hotkeys of y1, and at 4, and I get negative 22.2957, which is less than 0. So look at these two. Velocity is negative, acceleration is negative. If they're both negative, then speed is increasing. So I would say the speed is increasing at time equals 4 because velocity and acceleration have the same signs. And that's the work I would use to prove speed is increasing at time 4. All right, thank you so much. Bye.